Okay, this is a continuation of video 4. It got a little bit longer. I want to try to keep these all under 10 minutes so that I know you can squeeze them in when you have a moment here or there. So we're doing simplification of exponents, just like we were in the previous video. So 7 over 4 squared divided by 4 over 7 to the 5th power. The very first thing I'm going to do is deal with that problem. Whenever I'm dividing by a fraction, I am really multiplying by the reciprocal. So I'm going to flip this one upside down, change it to a multiplication sign. You never change that first one. And we're ready to go. So now I've got 7 squared times 7 to the 5th on the top. And 4 squared times 4 to the 5th on the bottom. That's 7 to the 2 plus 5, which is 7 to the 7. And on the bottom, that's 4 to the 2 plus 5, which is 4 to the 7th power. We could do this and find out that 7 to the 7th power is some large number that I don't know, and 4 to the 7th power is some other large number I'm not sure about. We could divide them and get something ugly. But this is a good place to stop for our exponent rules. Here we've got 3a squared b c cubed squared, this whole thing squared, divided by 3a cubed over 4b squared squared. Very first thing I'm going to do again is change this to a multiplication and flip this. Maybe I can flip like this. You go over there. You go up there. You go down there. Draw a new line. Yeah, that works. So we can do this. Now I'm going to go through, deal with my power of a powers, if I can, which I can. So 3a squared b c cubed squared. This squared is applied to every term on the inside. That's 3 squared, a to the 2 times 2, which is 4. b to the 1 times, it's a 1. If there's no number, it's a 1. 1 times 2, which is 2. And c to the 3 times 2, which is 6. And we're multiplying by, x is the wrong symbol today, we're multiplying by 4b squared squared. That 2, again, is going to get distributed to everything on the inside. That's 4 squared. That's 1 times 2, because there was a 1 there, which is 4 squared. And b to the 2 times 2, which is the same as b to the 4th power. On the bottom here, we've got 3a cubed. Now, I'm going to write this over 1 just so I remember there's a top and a bottom. I'm going to combine everything that I can. 3 squared times 4 squared. Those are small enough that I think I can write them out. That's 9 times 16. And for a's on the top, I've got 4 of them over here and nothing else. For b's, I've got 2 and another 4. So 2 plus 4, which is 6. And for c's, I've got 6. On the bottom, I've got a 1 and I've got a 3a cubed. Last thing I need to do is tidy up the number part and tidy up the a's. So 9 times 16 is got to be 144, and 144 over 3 is 48. So that's these numbers taken care of. And we have a to the 4 on the top and 3 on the bottom. We're subtracting. 4 minus 3 is 1. So there's just one a. I just write a. And there's still 6 b's and 6 c's. We'll do a couple like this, but where we also evaluate at the end. If you have something that's messy like this and it asks you to evaluate, it's probably a good idea. You don't have to, but it's probably a good idea to simplify first. You could put, if x is 3, you could put a 3 in there and a 3 in there and a 3 in there. And if y is 2, you could put a 2 in there and a 2 in there and a 2 in there, and just plug it into your calculator all in one big mess. But I think it's nicer to simplify it first. So the first thing I'm going to do is I'm going to look at that power of a power rule. it applies to my bracketed term, so I need to deal with that first. So I'm going to have x squared times x. This x has a 3 applied to it, so 1 times 3. This y has a 2 times 3, which is 6, over 3y times, I'm going to distribute here, x to the 2 times 3, which is x to the 6, and y to the 1 times 3, which is y cubed. Now I'm going to do my next round of distribution, which is multiply by the whole bracket. Luckily, that's pretty easy. So x squared times x cubed y to the 6th, that's just going to be x to the 2 plus 3 and y to the 6. That's x to the 5. And on the bottom, 3y times x to the 6th, y cubed, is, I'll just write them alphabetically. 3 is the only number, that comes first. The x's, there's going to be 6 of them. And the y's, there's going to be 3 times 1, which is going to be, well, 3 plus 1 if we're doing exponents. It's going to be 4. There's 4 y's down there. Last thing I need to do is clear up top and bottom. With the x's, I've got 5 on the top and 6 on the bottom. For the y's, I've got 6 on the top and 4 on the bottom. When they're top and bottom, when they're dividing, we subtract our exponents. And we've got that 3 down there on the bottom. So what we've got now is x to the 5 minus 6 is negative 1. Y to the 6 minus 4 is 2, so y squared over 3. I prefer, so we could be done here, but I prefer to move this guy down here. If we have x to the negative 1, that really should just be an x to the positive 1 hiding out at the bottom. Negative exponents really just mean they belong on the other side of the fraction. I think we've got 2 more here. Good. Oh, we didn't evaluate. Evaluate where x is 3 and y is 2. So now, if y is 2, that's 2 squared over 3 times x, which is 3. So 2 squared is 4, and 3 times 3 is 9. And that's 4 over 9. That's just as simple as it gets. For this one here, negative 8x to the 4y cubed over 5x y cubed squared times negative 3x squared y. Going to do the distributive parts if I can first. So we have negative 8 cubed x to the 4 times 3, which is 12, y to the 3 times 3, which is 9, and on the bottom we've got 5 squared x squared y to the 6th, 3 times 2 is 6, times negative 3 x squared y. Let's look at our numbers. At the top we have negative 8 cubed, and at the bottom we have 5 squared times negative 3. So negative 8 cubed is negative 512. And 5 squared is 25. 25 times negative 3 is negative 75. Negative divided by negative is going to be positive, and 512 over 75 is going to be, well, nothing nice. So we'll just leave it. So I know negative divided by negative is positive. I'm just going to leave it like that. Now we'll come back and look at our x's. On the top we've got 12. On the bottom we've got 2 over here and another 2 over here. So on the bottom we've got a total of 4. On the top we've got a total of 12. And 12 minus 4 is just 8. I'll just write it like this because I got room over here. For the y's, on the top we have 9. On the bottom we have 6 and another 1. So on the bottom we have a total of 7. And 9 minus 7 is 2. So I do 512 over 75, x to the 8, y squared. To evaluate where what x is 3 and y is 2, we would just plug a 3 in here and a 2 in there. We would get some giant number. I don't know. 512 times 3 to the 8 times 2 squared. 3 to the power of 8 is something 65, 61 times 512 is some other giant number times 2 squared times 4 is some other giant number. I don't know. I didn't plan this out in advance. This is messier than I would have liked. But anyway, it's 1, 3, 4, 3, 6, 9, 2, 8. And on the bottom, we got 75. So if we divide by 75, we don't get a whole number, but it's close to 179,159. So 179,159. And there's still, you might want a decimal form, you might not. You might want a fraction form. In decimal form, I guess at 179,159.04 will do. Oh, this is already past 11 minutes. Okay, that's fine, because this last one is so easy. Everything in brackets here to the power of 0. This is 1. Who cares what x or y were? This whole thing is 1. That's a nice end to this video. See you in the next one.